Hey guys, this is Mrs. Keith again, and now I'm going to do the inscribed angles in class practice, just making sure we go through these examples so it makes it clear how we work these problems. Okay, we're trying to find this angle right here. I know that it's an inscribed angle because its vertex is on the circle, so it should be half as big as the part of the circle that lies between the sides of that angle. So if this arc measure is 194, then I'm going to do 194 divided by 2 to figure out this angle is 97 degrees. Same thing here, inscribed angle, this is 40, so this piece of the circle that lies between the sides of that angle should be twice as big, so it's going to be 80 degrees. Pay attention to what they're actually asking you to find. I mean, they just wanted me to find GH right there. That arc GH was named with 2 letters, so it has to be less than 180 degrees, so they're talking about that arc right there. Okay, here on this example, this is an inscribed angle because its vertex is half as big, or its vertex is on the circle. The part of the circle that lies between the sides of that angle is this arc right here. I need to find that arc measure. I have the other 2 arc measures, so I can do 360 minus 62 minus 140. And when I do that, I find out that this arc measure is 158. So if I divide that by 2, if I say 158 divided by 2, I get that this arc measure this angle measure is 79. And so that's the equation I can set up. I can say 11x plus 2 equals 79. So solving that, I get that x equals 7. Okay, on this next example, again, an inscribed angle because its vertex lies on the circle. If this angle is 50, the arc measure is going to be twice as big, so it'll be 100. And now I can solve that equation. 9x minus 8 equals 100. So 9x equals 108, which makes x equal to 12. On the next example, I know that this inscribed angle right here that's marked as 68 degrees, the part of the circle that lies between it is going to be twice as big. So this arc measure over here, actually I'm not even sure I care about that. Let me erase that. Sorry about that. So I'm going to look at this right here. This inscribed angle right here is x. The part of the circle that lies between the sides of that angle is right here. So x is going to be half as big as that 160. We're going to do 160 divided by 2 to get x, which is going to be 80 degrees. Okay, and then if you'll notice, angle y, which is also inscribed, it should be half as big as the part of the circle that lies between its sides, which goes from here all the way over to here. So I need to know what that z is right there. I just figured out that x is 80. And then the angles in a triangle add up to be 180. So this angle has to be 32. And then that's an inscribed angle. It should be half as big as z. So z will have to be 64. And then to get angle y, it's going to be 160 plus that 64 divided by 2. And so I end up getting 112 when I do that. All right, on the next one, some important things to notice are that, first of all, this inscribed angle right here, it's drawn to a diameter. That makes it 90 degrees automatically. And then we've got these markings right here, which tells me that this is an isosceles right triangle. So these angles have to each be 45. So just some things to notice. And then this is an inscribed angle because its vertex is on the circle. And so it should be half as big as the part of the circle that lies between its sides. So that z has to be 90. They didn't ask me for z, but I just found it. Y, I'm going to erase some of this. It's getting a little busy. So we just found out that that was 90. Y is lying right here. And it's on either side of another diameter. And so y has to also be 90 degrees. X is also lying on, I mean, it's drawn as an angle that intercepts a diameter right here. So it's also going to be 90 degrees. All right, number 7. Number 7, again, we've got an inscribed angle where it's intercepting a diameter, so it has to be 90 degrees. That means 13x minus 1 equals 90. And then if I solve that, I get 13x equals 91, so x equals 7. All right, on the next one, this line right here is not a diameter because it's not going through the center of the circle. So we can't use that information. Instead, we're going to use the fact that this 114 right here is an inscribed angle. And so it will be half as big as the part of the circle that lies between its sides, which is all of this right here. So this has to be 228. And then I know that this is 78, this is 228. All three parts have to, the whole circle has to add up to be 360. So this is going to be 54. When I do 360 minus 228 minus 78, I get 54. And then this angle right here is an inscribed angle that's drawn to that 54. So that means that 7x plus 6 has to equal half as big as that 54. So I'll just write it like that. And now we can solve for that. So 7x plus 6 equals 27. 7x equals 21, so x equals 3. All right, on number 9, because I have a quadrilateral and I see that all of the vertices are drawn where they're actually touching the circle, that means opposite angles have to be supplementary. So angle y plus angle w has to equal 180. So I'm going to do 180 minus 51 to get angle w. And that tells me it's 129. So this is 129. Another thing I notice is that this 51 right here, it's drawn from here to here. So 51 has to be half as big as this intercepted arc. So this is going to be 102 from here to here. And then I know this part of it's 67. So if I do 102 minus 67, I get that this part is 35. So then that will help me figure out that this other arc is going to be 157 because all of them have to add up to be 360. So now that when it asked me to find angle W, let me erase some of this. We found out this was 35. Angle W is drawn from here to here. So all of this adds up to be, let's see, 192. So if I do 192 divided by 2, I get that angle V is 96 degrees because it has to be half as big as that 192. And then angle X and angle V have to be supplementary. And so I'm going to say that here, angle V plus angle X has to add up to be 180. So 180 minus that 96 tells me that angle X is 84. And that's all of that circle. Okay, on this next one, again, I have an inscribed angle right here. It's drawn to a diameter. So that makes this a right angle. This is 180 degrees over here. And then this side over here is also 180 degrees. So I know 13x minus 10 plus 7x minus 10 equals 180. So combining like terms, I get 20x minus 20 equals 180. 20x equals 200. And I just wrote that wrong. Sorry. 20x equals 200, so that makes x equal to 10. All right, and then it's actually asking me to find angle NLM, which is this angle right here. I know this angle was 90. I know that this angle NLM is drawn right here to this angle. So if I do 7 times 10 minus 10, I get that arc measure is 60. And then this angle is an inscribed angle, which is half as big, so it'll be 30. And that's all that it's asking me for. All right, on this one, now we're going to have a system of equations. I know you love those. So opposite angles are supplementary if it's a quadrilateral inscribed inside of a circle. So that means that 7x plus 1 plus 2y plus 74 equals 180. That equation has two letters or two variables, therefore you need a second equation. So the other two angles are also supplementary because they're opposite angles. So 2y plus 100 plus 6x minus 10 equals 180. All right, so I'm going to kind of clean that up a little bit. I'm going to get my x's and my y's and my numbers together. So that first equation becomes 7x plus 2y equals, I'm going to subtract the 1 and the 74 from both sides, and I get 105. On the second equation, I'm going to put the x first, so 6x, and then I'll put the 2y, and then that equals, when I move the 100 and the negative 10 combined to be 90, and when I move that over to the other side, it becomes 90. All right, it'd be really nice to be able to do elimination here. And I've got, and the y's have the same number, but they need to have different signs. So I'm going to multiply through by a -1, which changes the sign of all of those. And now I can add the equations. So 7x minus 6x is x. This has been eliminated. And then 105 minus 90 is 15. So x equals 15. And I can plug that back into either equation to solve for y. I'm gonna plug it back into this one. So 7 times 15 plus 2y equals 105. That gives me 105 plus 2y equals 105. When I subtract 105 from both sides, I get 2y equals 0. And then when I divide by 2, I end up with just y equals 0. Which is just fine to have y equal to 0. I want to check my answers by plugging it back in and making sure that everything is going to add up to be, opposite angles are supplementary. So when I plug in 7x plus 1, let's see, 7 times 15, that's 106 for this angle. And then this will be 74 when I plug in 0 for y, and those are supplementary, so that worked out. When I plug in 0 for this angle, I get 100. And when I plug in 6 times 15, I get 90 minus 10, which is 80. And then those are supplementary. So I've checked my work to make sure it's right. All right, so those are our examples. Thanks, y'all.